far beyond the warmth of the sun, past the familiar worlds, past the golden rings of Saturn, and past the pale blue-green silence of Uranus, there is a planet that lives in the deep outer dark, Neptune. From a distance, it looks calm. A cold blue world, wrapped in clouds, moving slowly through the far edge of the solar system. Sunlight reaches it, but only faintly, like a memory from another place. Out here, the sun is no longer a blazing presence in the sky. It is a small bright point, too distant to warm the worlds that orbit beneath it. And around this remote planet, there is a moon that should not be there. Its name is Triton. At first, Triton may not look like a mystery. It is simply a frozen moon, circling a frozen planet. A pale, icy world moving through the darkness around Neptune. But the mystery is not in how it looks from far away. The mystery is in the direction it moves. Triton orbits Neptune backward, not slightly tilted, not just a little unusual, backward. While Neptune spins in one direction, Triton travels the other way around it. It moves against the rotation of the planet it belongs to, and in planetary science, that one detail is not small. It is not a curiosity, it is a clue. Because large moons are not supposed to do this. Across the solar system, the biggest moons usually follow a simple pattern. They move in the same direction their planets spin. Jupiter's great moons do it. Saturn's major moons do it. Uranus, even with its strange sideways tilt, still carries its large moons in an orderly rhythm around its equator. That is what we expect. Large moons normally form from disks of gas, dust, and ice surrounding young planets. The planet spins, the disk spins with it, and the moons that grow inside that disk inherit the same motion. They are born into the rhythm of their planet. They follow. They belong. But Triton does not follow Neptune's rhythm. It cuts against it. And that single backward motion tells us something extraordinary. Triton may not have been born around Neptune at all. It may have formed somewhere else, far away from this blue planet, in the frozen outskirts beyond Neptune's orbit. It may have once moved freely around the sun, like Pluto, like the icy bodies of the Kuiper Belt, carrying its own history through the darkness. Then, sometime in the ancient past, Neptune's gravity reached out, and Triton never escaped. That is why this moon feels different from the others. It is not just another satellite in Neptune's system. It is a captured world, a place that may have had another life before it became a moon, a place that still carries signs of a lost origin. And once you know that, everything about Triton begins to change. Its backward orbit is not just strange, it becomes evidence. Its icy surface is not just cold, it becomes a memory of where it came from. Its thin atmosphere, its frozen nitrogen, its strange young terrain, and the dark geysers seen by Voyager 2 all begin to feel like pieces of a much larger story. A story about a world that did not begin where we find it today. A story about a moon that may once have been free. And perhaps the most haunting part is this. Triton is not a tiny captured rock. Neptune has small moons, distant moons, irregular fragments that could easily have been grabbed by gravity. But Triton is not one of those. Triton is large. It is bigger than Pluto. It is round. It has layers inside it. It has a surface shaped by ice and time. It has a thin atmosphere, barely there, but real. And beneath its frozen crust, some scientists suspect there may even be a hidden ocean, sealed away from the sun, under miles of ancient ice. So when we say Triton was captured, we are not talking about Neptune catching a drifting stone. We are talking about a planet capturing an entire world. That is what makes Triton so unsettling and so beautiful. It circles Neptune today, but it does not move like a moon born there. It does not behave like something that grew beside the planet. It moves as if it remembers another path, another home, another life before Neptune. And the deeper we look, the clearer the question becomes. How did a world this large end up moving backward around Neptune? How did Neptune capture it? And what happened to everything that was already there when Triton arrived? To answer that, we have to travel farther outward, into the coldest regions of the solar system, and approach Neptune not as a simple planet with moons, but as the scene of an ancient gravitational mystery. Because Triton's backward orbit is only the first clue. The real story begins when we ask what kind of world Triton was before Neptune took it. To understand Triton, we first have to understand where Neptune is. Not just as a point on a diagram, not just as the eighth planet from the Sun, but as a real place, far beyond the comfortable part of the solar system, where distance changes everything. Begin near Earth. Here, the Sun dominates the sky. Its light shapes the day, warms the oceans, drives the winds, and gives life a steady rhythm. The Moon circles above us in a familiar path, bright and silent, bound to Earth in a way that feels almost natural. But as we move outward, that familiarity begins to fade. Mars passes behind us first, small and rusty, carrying its dry valleys and frozen poles. Beyond it, the asteroid belt spreads out like a thin field of ancient debris. Then Jupiter appears, enormous and bright, surrounded by its own miniature solar system of moons. Io, Europa, Ganymede, and Callisto move around Jupiter in an ordered dance. They are not random bodies. They are part of Jupiter's history. They formed in its neighborhood. They move in the direction we expect. They belong. Farther out, Saturn rises from the darkness, wrapped in rings so wide and delicate, they look almost unreal. Its moons travel through that system, like pieces of a grand design. Titan, Enceladus, Rhea, Dione, each one following the larger rhythm of Saturn. Then comes Uranus, pale and quiet, tipped dramatically onto its side. Uranus is strange in its own way. It rotates almost sideways, as if something enormous struck it long ago and changed its orientation forever. And yet, even there, its major moons still follow the planet's tilted equator. They still move with the system that made them. By the time we leave Uranus behind, the Sun has become much smaller. Its light no longer fills space with warmth. It still shines, of course, but it feels distant now. We are traveling into a region where the solar system becomes slower, darker, and colder. The planets are separated by immense gaps. The familiar worlds of the inner system are now far behind us. Then Neptune appears. A deep blue planet at the edge of the classical solar system. It is beautiful, but not gentle. Its winds can race faster than the speed of sound. Its atmosphere is filled with methane, hydrogen, and helium. Its color is calm to the eye, but the planet itself is dynamic, restless, and powerful. And it is far. So far that sunlight reaching Neptune is only a tiny fraction of what Earth receives. From Neptune, the Sun would not look like the blazing disk we know. It would look more like an intensely bright star. Still the center of the system, still powerful in a gravitational sense, but no longer close enough to bring warmth in the way we understand it. This is the region where Triton lives today. A frozen moon orbiting a frozen blue planet, nearly 3 billion miles from Earth. But Neptune is not just far from us. It is also close to something else, the Kuiper Belt. Beyond Neptune's orbit lies a vast, cold population of icy bodies. Some are small, some are ancient fragments, some are large enough to be rounded worlds, like Pluto. This distant region is not empty. It is a deep reservoir of frozen material left over from the early solar system. And that matters because Triton does not seem like a moon that formed peacefully beside Neptune. It seems like something from that outer reservoir. something Neptune did not create, something Neptune captured. Imagine the early solar system, not as the neat arrangement we see today, but as a place of movement and instability. The giant planets were not always in their present positions. Their gravity shaped the outer solar system over time. Worlds were scattered. Orbits changed. Icy bodies were pushed inward, thrown outward, or sent into entirely new paths. In that ancient chaos, Neptune was not simply sitting at the edge of the solar system, waiting quietly. It was part of a much larger gravitational reshuffling. As Neptune moved and interacted with the icy bodies around it, close encounters became possible, and in one of those encounters, a large world may have passed too close. That world may have been Triton. Before it became Neptune's moon, Triton may have belonged to the same distant population as Pluto. It may have traveled around the sun on its own path, far from any giant planet, covered in ices that could only survive in the deep cold. Nitrogen, methane, carbon monoxide, materials that would be gases closer to the sun, but out there, in the Kuiper Belt, could freeze onto a surface and shape a world. This is why Triton feels so unusual. Its story does not begin with Neptune alone. It begins farther out, in a colder and older part of the solar system. A place where sunlight is weak. A place where worlds move slowly. A place where icy bodies can remain preserved for billions of years, carrying clues from the time when the planets were still forming. And then, somehow, Triton left that place. Or perhaps more accurately, it was taken from it. That is the quiet tension at the center of this moon. Triton is physically bound to Neptune today. It circles the planet once every few days. It rises and sets over Neptune's blue clouds. It is part of Neptune's sky. But its chemistry, its orbit, and its behavior all point away from Neptune. They point back toward the frozen outskirts, back toward Pluto, back toward the Kuiper Belt, back toward a life before capture. And this is where the mystery becomes much deeper. Because if Triton truly came from beyond Neptune, then it was not just placed gently into orbit. A body moving around the sun does not simply decide to become a moon. Gravity can bend its path, but to capture it permanently, Neptune had to change its energy. Triton had to lose enough speed, enough freedom, to become trapped. That is not easy. A small object might be captured more easily. A tiny rock, a comet fragment, an irregular piece of debris. Those can end up in strange orbits around giant planets. The outer solar system is full of such captured objects. But Triton is not small debris. It is a world. So the question becomes sharper. What kind of event could take a world from the Kuiper Belt and bind it forever to Neptune? What kind of encounter could turn a free icy body into a backward moon? To answer that, we have to look more closely at the rule Triton breaks, the rule that nearly every other large moon follows. Because once we understand that rule, Triton's backward motion stops looking like a simple oddity. It becomes a fingerprint of an ancient capture. Most large moons are not accidents. They are not random objects that wandered too close to a planet and happened to stay. They are usually born inside the same system as the planet they orbit. When a giant planet forms, it does not appear alone. In the early solar system, a growing planet was surrounded by a spinning disk of gas, dust, ice, and rock. This disk moved around the young planet in the same general direction that the planet itself was rotating. Inside that disk, small particles collided and stuck together. Over time, they became larger pieces. Then those pieces became moons. This is why the largest moons usually follow an orderly pattern. They orbit in the same direction their planet spins. They are not simply circling the planet. They are preserving the memory of how that system formed. Their motion is a fossil of the ancient disk that gave birth to them. Jupiter shows this clearly. Its four great moons, Io, Europa, Ganymede, and Callisto, move around Jupiter in the same direction as the planet's rotation. They are large, round, and organized. They sit close to Jupiter compared with its many distant irregular moons. Their orbits are not random. They look like the product of formation. Like planets around a star, they grew in a disk. Saturn tells a similar story. Titan, Saturn's largest moon, moves in the expected direction. So do many of Saturn's other major moons. Enceladus, Rhea, Dione, Tethys, they all share the same broad motion around Saturn. Even though Saturn's system is complex, with rings, small moons, icy fragments, and gravitational interactions, the large moons still carry the basic signature of belonging. They formed with Saturn. They follow Saturn. They move as part of Saturn's original architecture. Even Uranus, one of the strangest planets in the solar system, keeps this rule. Uranus is tilted almost completely onto its side. Its seasons are extreme. Its rotation is unusual. Its entire system looks as if it was disturbed by some enormous ancient event. And yet, the major moons of Uranus still orbit along the planet's tilted equator. They did not abandon the system's rhythm. They moved with it. This is what makes Triton so important. Triton does not simply have an unusual orbit. It breaks the rule that large moons are supposed to follow. Around Neptune, Triton moves backward. The scientific word for this is retrograde. It means that Triton orbits Neptune in the opposite direction of Neptune's rotation. If you could hover above Neptune and watch the planet spin beneath you, Triton would be moving the wrong way around it. And for a small object, that would not be shocking. The outer solar system contains many small captured moons. Tiny bodies can be pulled into strange orbits around giant planets. Some travel far from their planets. Some move in tilted paths. Some orbit backward. These small moons are often thought to be captured asteroids, comet-like objects, or fragments from collisions. A small captured moon is not unusual, but Triton is not small. That is the problem. Triton is one of the largest moons in the solar system. It is big enough to be round under its own gravity. It is larger than Pluto. It has a complex surface. It has a thin atmosphere. It has ices that shift and change. It has signs of activity. A world like that should not be casually captured. And a world like that should not form backward inside Neptune's original moon-forming disk. That is why Triton's orbit matters so much. It is not just a direction, it is a contradiction. If Triton formed beside Neptune, it should have inherited Neptune's direction of motion. It should have moved prograde, like other large moons. It should have followed the natural flow of the disk from which it formed. But it does not. So scientists are left with a different answer. Triton likely came from somewhere else. Its backward orbit is the first and strongest clue that it was captured. It was not born as a normal Neptunian moon. It was added later, after Neptune already existed, after the original system had already formed. That makes Triton more than a moon. It makes it evidence of an event. Somewhere in the early history of the outer solar system, Neptune encountered a large icy body. That body did not simply pass by and continue on its way. Something changed. Energy was lost. A path around the sun became a path around Neptune, and the result is still there today. A large moon moving backward through Neptune's sky. But there is another reason Triton's orbit feels so strange. A moon born with its planet usually has a kind of long-term stability. Its orbit may change slowly. Tidal forces may push it outward or reshape its path over billions of years. But the relationship is broadly cooperative. The moon and planet are moving in the same direction, sharing the same rhythm. A retrograde moon is different. Because Triton moves against Neptune's rotation, the tidal relationship between them is not the same as the relationship between Earth and our moon. Earth's moon is slowly moving away from Earth, very slowly, but measurably. The tides transfer energy in a way that pushes the moon outward over time. Triton is different. Its orbit is slowly evolving inward. Not quickly, not in a way anyone could notice in a human lifetime, but over enormous spans of time, the direction of the tidal exchange works against it. Triton is not gently drifting away from Neptune. It is slowly being drawn closer. This does not mean Triton is in immediate danger. The timescale is vast, far beyond anything human civilization can measure directly. But it means the relationship between Triton and Neptune is not a peaceful final arrangement. It is temporary. Triton is captured, bound, and slowly changing. That gives the moon an unusual kind of tension. It is not only strange because of where it may have come from, it is strange because its present orbit still carries the consequences of that ancient capture. Every time Triton circles Neptune, it is repeating the clue. Backward, backward, backward. A quiet motion in the dark, telling us that this world was not born here. And once we accept that, we can begin asking the next question. What kind of world was Triton before Neptune? If it did not grow from Neptune's disk, if it did not begin as one of Neptune's original moons, then it must have had another identity, another orbit, another place in the solar system. And this is where the story becomes even more interesting. Because Triton does not only move like a captured object, it also looks like one. Its frozen surface, its nitrogen ice, its methane, its thin atmosphere, and its similarities to Pluto all point in the same direction, away from Neptune and toward the Kuiper Belt. Triton may not be a moon that became strange. It may be a dwarf planet-like world that became a moon. And to understand that, we have to stop seeing Triton as a small companion to Neptune. We have to see it for what it really is. Not a rock, not a fragment, but an entire frozen world, carrying the chemistry of a place far beyond the planet it now circles. If Triton were small, its story would be easier to explain. A little frozen rock moving backward around Neptune would not surprise us very much. The giant planets have many small moons with strange orbits. Some are tilted, some are distant, some move backward. Many are probably captured objects, fragments left over from the long and violent history of the solar system. Small objects are easy for gravity to disturb. They can be pulled, scattered, broken apart, and captured more easily than large worlds. A tiny body passing near a giant planet can lose energy through a collision, a gravitational interaction, or a close encounter with another moon. Over billions of years, the outer solar system has had plenty of time to collect such fragments. But Triton is not one of those fragments. Triton is enormous. It is about 2,700 kilometers across, making it one of the largest moons in the solar system. It is larger than Pluto, the most famous dwarf planet. It is massive enough for gravity to pull it into a rounded shape. It is not an irregular shard of ice. It is not a loose piece of debris. It is a world, and that changes everything. A world this large carries its own history. Its gravity shapes its interior. Its materials separate into layers. Dense rock sinks inward. Lighter ice forms outer shells. Heat can be stored, moved, and released over time. The surface does not have to remain frozen in the same shape forever. It can crack. It can flow. It can be resurfaced. Triton has all the signs of being far more than a simple captured object. Its surface is covered in exotic ices, nitrogen, methane, carbon monoxide, and water ice. On Earth, nitrogen is part of the air we breathe. It moves invisibly around us as a gas, but on Triton, the temperature is so unimaginably low that nitrogen can freeze onto the ground as frost. The surface temperature is around -235 degrees Celsius. That is not cold in any familiar human sense. It is colder than any natural environment on Earth. It is cold enough that ordinary materials behave in strange ways. Gases become solids. Ice becomes as hard as rock. The difference between atmosphere and ground becomes delicate, almost fragile, because some of Triton's frozen nitrogen can slowly turn into gas and then fall back again as frost. This gives Triton something that many small moons do not have: an atmosphere. It is extremely thin, almost a vacuum by Earth standards, but it is real. A faint layer of nitrogen, with traces of methane, clings to the surface. It is not thick enough to breathe, not thick enough to soften the landscape, not thick enough to make Triton feel alive in any Earth-like way. But it is enough to move. It is enough for winds to carry dark material across the frozen plains. It is enough for seasonal changes to matter. It is enough for Triton to have weather, in the faintest and coldest sense of the word. That alone makes Triton unusual. But the surface is even stranger. When Voyager 2 flew past Triton in 1989, scientists expected a cold, ancient, heavily cratered moon. That would have made sense. A world so far from the sun should have lost most of its internal heat long ago. It should have become quiet. Its surface should have been covered with impact craters, recording billions of years of collisions with icy debris. But Triton did not look that way. It looked young. Not young as in newly formed, but young in the geological sense. Much of the surface seen by Voyager 2 had surprisingly few impact craters. That means something had erased them, something had covered, reshaped, or renewed large parts of the terrain after the old craters formed. For a world near Neptune, that is deeply strange. The farther we go from the sun, the less energy there is. Sunlight is weak. Temperatures are extreme. Chemical reactions slow down. Ice becomes rigid. Worlds are expected to become quiet and ancient. Yet Triton seems to have refused that fate. Voyager 2 saw smooth plains. It saw ridges and fractures. It saw strange, rounded depressions in a region often compared to the skin of a cantaloupe melon. It saw landscapes that did not look like simple impact scars. They looked like the results of internal processes: movement from below, deformation of the crust, resurfacing by exotic icy material. And then came the most surprising discovery: geysers, dark plumes rising from the surface. On a moon so cold that nitrogen lies frozen on the ground, Voyager 2 saw signs of material being launched upward into Triton's thin atmosphere. The plumes rose high above the icy surface, then drifted sideways with the winds, leaving dark streaks across the bright frost. This was not supposed to happen. At Neptune's distance, sunlight is weak. Triton is small compared with major planets. Its surface should be frozen into stillness, and yet something was active enough to push material into the sky. That one discovery changed the way scientists looked at Triton. It was not just a captured moon. It was a captured moon that still had energy. Some of that activity may be driven by sunlight interacting with transparent nitrogen ice. Even weak sunlight trapped beneath a thin layer of frost might warm darker material below and build enough pressure to erupt. This would be a kind of cold, alien geyser, not boiling water, not steam, but nitrogen gas and dark particles bursting through the ice. But that may not explain everything. Triton's young terrain, its fractures, its smooth plains, and its strange surface patterns suggest a deeper story. Some activity may come from inside the moon itself. Heat may still be escaping from beneath the crust. Icy material may have moved upward in the past. There may have been cryovolcanism, a form of volcanism where the erupted material is not molten rock, but slushy ice, ammonia-rich water, nitrogen, or other frozen compounds. On Earth, volcanoes remind us of heat, On Triton, volcanism would remind us that even ice can behave like lava if the world is cold enough. This is one of the most important things to understand about Triton. It does not need to be warm like Earth to be active. In the outer solar system, the rules are different. Water ice can become bedrock. Nitrogen ice can move like a volatile frost. Methane can freeze onto the ground. A small amount of heat, almost nothing by Earth standards, can become powerful when the entire surface is only a few degrees above absolute zero. So Triton's coldness does not make it boring. It makes its activity even more mysterious. Every sign of movement demands an explanation. Every smooth plane asks what covered it. Every fracture asks what cracked the ice. Every plume asks what pushed material upward. Every patch of young terrain asks how a world so far from the sun kept renewing itself. And that brings us back to the capture. If Triton had remained alone in the Kuiper Belt, it might have become something more like Pluto, still complex, still fascinating, but not forced into an intimate gravitational relationship with a giant planet. But Neptune changed Triton's story. Capture may have heated it. Tides may have flexed it. Its orbit may have pumped energy into the interior when it was first trapped. The same event that made Triton a moon may also have kept it from becoming completely dead. That is what makes this world so compelling. Triton's backward orbit tells us it came from somewhere else. Its composition tells us that somewhere else may have been the Kuiper Belt. Its size tells us it was not just debris. And its surface tells us that after Neptune captured it, Triton did not simply freeze into silence. It changed. It responded. It became a world shaped by loss, gravity, ice, and time. So before we can understand Triton as Neptune's moon, we have to imagine it before Neptune, before the backward orbit, before the icy surface was reshaped by tides, before Voyager 2 saw its geysers, before it became the strange pale companion circling a blue planet in the dark. We have to imagine Triton as a free world, a world beyond Neptune, a world moving through the Kuiper Belt, under a distant sun, perhaps not so different from Pluto. And that may be the key to everything. Before Triton became Neptune's moon, it may have belonged to a very different place. Not a planet sky, not a stable family of moons, not the cold blue shadow of Neptune, but the Kuiper Belt. This distant region begins near Neptune's orbit and stretches outward into the deep cold beyond the planets. It is not empty space. It is a vast, scattered population of icy bodies, ancient leftovers from the formation of the solar system. Some are small. Some are irregular. Some are dark and frozen, moving slowly around the sun in paths so distant that a single orbit can take centuries. And a few are large enough to become worlds. Pluto is the most famous of them. For a long time, Pluto felt like the lonely edge of the solar system, a small, distant planet, then later a dwarf planet, orbiting far from the warmth of the sun. But as telescopes improved, we learned that Pluto was not alone. It was part of a much larger population, a cold outer reservoir filled with icy bodies that never became full planets. These objects are old, very old. They are built from materials that have survived since the early solar system: water ice, methane, nitrogen, carbon monoxide, and rock. Closer to the sun, many of these materials would not remain frozen on a surface for long, but in the Kuiper Belt, the temperatures are low enough for them to persist across billions of years. That makes the Kuiper Belt more than a distant region. It is a kind of deep freezer for planetary history. A place where ancient materials can remain preserved, far from the heat and chaos of the inner solar system. A place where worlds can hold on to chemistry that would be lost almost anywhere else. And Triton seems to carry that chemistry. Its surface is rich in frozen nitrogen, It contains methane and carbon monoxide ice. It has a thin nitrogen atmosphere, much like Pluto. Its size, density, and composition all suggest that it may have formed in the same outer population of icy worlds. This is why scientists often compare Triton with Pluto. They are not identical. Their histories are different. Their surfaces are different. Their environments are different. But they appear to be made from similar kinds of material. They belong to the same broad family of frozen outer solar system worlds. Pluto remained free. Triton did not. That contrast gives Triton's story its emotional weight. Imagine two icy worlds born in the distant outskirts of the solar system, both formed far from the sun, in a region where nitrogen can freeze, methane can coat the ground, and time moves slowly. One of them continued orbiting the sun, becoming the Pluto we eventually visited with New Horizons. The other passed too close to Neptune, and everything changed. This does not mean Triton was once exactly like Pluto. We should be careful with that. Triton is larger than Pluto, and its later history around Neptune has reshaped it in ways Pluto never experienced. But the comparison helps us understand what Triton may have been before capture. It may have been a dwarf planet-like world, a free icy body, a world with its own orbit around the sun, a world that did not belong to any planet. That idea matters because it changes how we see Triton today. When we look at Triton, we are not simply looking at a moon that formed around Neptune. We may be looking at a captured piece of the Kuiper Belt, preserved inside Neptune's system like a fossil from somewhere else. Its current address is Neptune, but its birthplace may have been the outer dark. And in the early solar system, that outer dark was not as quiet as it is today. The planets were still settling into their final arrangement. Giant worlds were interacting with one another. Neptune may not have always been where it is now. Many models of solar system history suggest that the giant planets shifted their orbits over time, scattering icy bodies as they moved. This period would have been chaotic. Not chaotic in the sense of explosions everywhere, but chaotic in the gravitational sense. Orbits changed. Small bodies were thrown into new paths. Some were pushed inward, some were flung outward. Some may have been removed from the solar system entirely. The Kuiper Belt we see today may be only a remnant of a much larger original population. In that early era, Neptune would have had far more chances to encounter large icy bodies than it does now. Today, the Kuiper Belt is widely spread out, and close encounters between Neptune and large objects are rare. But long ago, when the outer solar system was being rearranged, those encounters may have been much more common. This gives us a possible setting for Triton's capture. Not a calm Neptune waiting at the edge of space, but a migrating Neptune moving through a crowded field of icy bodies, a planet with enormous gravity, a region filled with ancient frozen worlds, and somewhere among them, Triton. At this point, Triton was not yet a moon. It was not moving backward around Neptune. It was not locked into a 5-day orbit. It was not rising over blue clouds or falling into Neptune's shadow. It was still its own world. Perhaps it had a companion. Many Kuiper Belt objects are found in pairs, orbiting one another as they travel around the sun. Pluto has Charon. Other distant icy bodies have partners too. In the cold outer solar system, binary worlds are not rare. This detail may become very important, because one of the leading ideas for how Neptune captured Triton involves not a single world passing by, but a pair of worlds. A binary system. Two icy bodies bound to each other, moving together through the outer solar system. If Triton was once part of such a pair, then Neptune's gravity did not simply grab it out of empty space. Instead, Neptune may have torn a relationship apart. One body stayed, the other was thrown away, and Triton became Neptune's moon. We do not know the full details. We do not know what Triton's original orbit looked like. We do not know whether it truly had a companion, or how large that companion may have been. We do not know exactly when the capture happened, but the clues point strongly in one direction. Triton did not begin as a normal moon. It began somewhere colder, older, and farther out. It carried the ingredients of the Kuiper Belt. It moved through the deep outer solar system. It may have shared its path with another icy body, and then it entered Neptune's reach. From that moment on, Triton's story was no longer its own. Neptune's gravity changed its path forever. And this is where the quiet origin story becomes a dramatic turning point. Because capturing a world is not simple. A planet cannot keep a passing object unless something removes enough energy from that object's motion. Without that loss of energy, the object simply swings around the planet and escapes back into space. So Triton could not have become Neptune's moon by chance alone. Something had to happen during the encounter. Something strong enough to turn a free Kuiper Belt world into a permanent satellite. Something powerful enough to create the only large backward moon in the solar system. And perhaps something violent enough to change Neptune's entire moon system. That is the next knot in Triton's story. How does a planet steal a world? A planet cannot simply capture a world because it is powerful. Gravity can pull. Gravity can bend a path. Gravity can drag an object closer for a while. But if that object is moving too fast, it will not stay. It will fall toward the planet, curve around it, and escape again. This is one of the most important parts of Triton's mystery. Neptune is massive. Its gravity is strong. But strength alone is not enough. If Triton once moved freely around the Sun, then it already had its own orbital energy. It was not waiting to become a moon. It was traveling through the outer solar system on a path of its own. For Neptune to keep Triton, something had to change. Triton had to lose energy. Not all of it, just enough. Enough to turn a temporary encounter into a permanent orbit. Enough to make a passing world become a captured moon. And that is not easy. Imagine a car moving down a highway. If it passes near an exit, it does not suddenly become trapped on a circular road, unless something slows it down and redirects it. Without losing speed, it simply continues onward. A world passing near Neptune behaves in a similar way. Gravity can curve the path, but unless energy is removed, the object leaves again. So the question becomes clear. What slowed Triton down? For small bodies, there are several possibilities. A tiny object might pass through gas around a young planet and lose speed through drag. It might collide with another moon. It might interact with several smaller objects in a way that changes its orbit. But Triton is too large for these simple answers to feel satisfying. A body more than 2,700 kilometers wide cannot be slowed easily. Gas drag would not do much unless the conditions were extreme. A direct collision large enough to capture Triton might also destroy Triton, or at least scar it beyond recognition. And a single close pass around Neptune would usually not remove enough energy to make such a large world stay. This is why one of the most compelling ideas involves not Triton alone, but Triton with a partner. A binary world. In the Kuiper Belt, many icy objects are not solitary. Some travel in pairs, two bodies bound to each other by gravity, while they both orbit the Sun. Pluto and Charon are the most famous example. Charon is so large compared with Pluto that the two almost feel like a double world, turning around a shared center of mass in the dark. The outer solar system is a place where such pairings can happen. In the slow cold of the Kuiper Belt, icy bodies can become gravitational partners. They move together, not as planet and moon in the usual sense, but as companions traveling around the Sun. Triton may have once been part of such a pair. If that is true, then its capture by Neptune becomes easier to imagine. Picture two icy worlds moving together through the distant solar system. They are bound to each other, slowly orbiting their shared center of gravity. Around them, the sun is small. Neptune is nearby, not as a distant blue dot, but as a giant gravitational presence. The pair passes too close. Neptune's gravity pulls on both bodies, but it does not pull on them equally. The one closer to Neptune feels a stronger pull. The one farther away feels a weaker pull. Across the distance between the two companions, that difference becomes a tidal force, a stretching force, a separating force. If the encounter is close enough, Neptune's gravity can overpower the bond between the two icy bodies. The pair is torn apart. One body gains energy and is thrown away. The other loses energy and falls into Neptune's grasp. This is the heart of the binary capture idea. Neptune did not need to stop Triton by crashing into it. It did not need to slow Triton with gas. It only needed Triton to arrive with a companion, and then use the energy of that relationship. One world escaped with extra energy. Triton stayed behind with less. And in that exchange, Neptune captured a moon. There is something almost quiet about the violence of this event. No fire, no explosion, no sound in space, just gravity, acting with perfect indifference, changing the fate of worlds. One path bends inward, one path is thrown away. A partnership that may have lasted for millions of years ends in a single close encounter. If Triton had a companion, we do not know where that companion is now. It may have been scattered deeper into the Kuiper Belt, still orbiting the sun today under a name we do not recognize. It may be one of the distant, icy objects we have already catalogued, its connection to Triton long erased by time. It may have been thrown onto a long, stretched orbit that carries it far beyond Neptune, too dim for our telescopes to easily find. Or perhaps it was ejected completely. A lost icy world, no longer bound to the sun, drifting between the stars. We cannot know. The event happened billions of years ago. The outer solar system has changed since then. Orbits have shifted. Bodies have been scattered. Any evidence of Triton's lost companion may be impossible to recover. But the idea adds a haunting layer to Triton's story. Before Neptune, Triton may not have been alone. And when Neptune captured it, something else may have been lost. This is not just dramatic storytelling. It also helps solve a real scientific problem. A binary encounter provides a natural way for Triton to lose energy without being destroyed. It explains how a large Kuiper Belt object could become bound to Neptune. And it fits what we see today. A massive moon in a retrograde orbit, moving backward around a planet where it likely did not form. But capture was only the beginning. When Triton first became bound to Neptune, it probably did not enter the neat, nearly circular orbit we see today. A captured object would likely begin on a highly stretched path, an eccentric orbit. It would swing far away from Neptune, then dive much closer again and again. Each close approach would have been intense. Neptune's gravity would pull harder on Triton's near side than its far side. Triton would flex, its interior would deform. Ice and rock inside the moon would experience friction. Orbital energy would slowly turn into heat. This process is called tidal heating. And for Triton, it may have been transformative. A world that had spent its early life in the deep cold of the Kuiper Belt was suddenly locked into a close gravitational relationship with a giant planet. Each orbit squeezed and stretched it. Each close pass warmed its interior. Over time, Triton's elongated orbit became more circular, but the energy lost during that process did not simply disappear. Some of it went into Triton itself, into its ice, into its rock, into its deep interior. This may be one of the reasons Triton is not a dead, frozen relic today. The capture that stole Triton from its original path may also have heated it from within. The same gravitational event that made it Neptune's moon may have helped melt parts of its interior, reshape its surface, and perhaps even create or preserve a hidden ocean beneath the ice. In other words, Neptune did not just capture Triton. Neptune changed Triton. It turned a distant icy world into something more active, more complex, and more mysterious than it might have been if it had remained free. But Triton was not the only thing changed by this event. Neptune changed too. Or more precisely, Neptune's moon system changed. Because if Neptune already had moons before Triton arrived, those moons would have suddenly found themselves sharing space with a large captured world, moving on a strange, tilted, possibly stretched backward orbit. That would not have been a peaceful situation. A large moon moving backward through a system of normal moons is dangerous, not because it is evil, not because it chooses destruction, but because orbital motion has consequences. If two bodies move in the same direction, their encounters can be relatively gentle. Their speeds partly match. Their gravitational interactions unfold over time. But if one body moves backward while others move forward, encounters become much more violent. The relative speeds are higher. Close passes are more disruptive. Orbits can be twisted, stretched, or broken. Smaller moons can be flung outward, pushed inward, or sent into collisions. So Triton's arrival may have been more than a capture. It may have been an invasion of an existing moon system. Before Triton, Neptune may have had a family of regular moons, perhaps not exactly like Uranus, but more orderly than what we see today. Moons that formed with Neptune, moons that moved in the same direction, moons that belonged. Then Triton arrived from outside. A huge icy world, moving the wrong way, crossing through the system again and again as its orbit slowly settled. The original moons would have been in the way. Some may have collided. Some may have been shattered. Some may have been thrown into Neptune. Some may have been ejected into distant orbits. And some fragments may have later reassembled into the small inner moons we see today. This possibility makes Neptune's current moon system feel like the aftermath of an old event. Compared with Jupiter, Saturn, and Uranus, Neptune's system is strange. It has Triton dominating the system, and then it has much smaller moons, many of them irregular, faint, or distant. It does not have a rich family of large regular moons like the other giant planets. That absence may be a clue. Maybe Neptune once had more. Maybe Triton changed that. Maybe the blue planet's quiet moon system is not simply incomplete. Maybe it is damaged. And if that is true, then Triton is not only a captured moon, it is the reason Neptune's moon system looks the way it does today. A stolen world that arrived from the Kuiper Belt. A backward moon that disturbed everything around it. A captured body that may have destroyed, scattered, and reshaped an entire family of moons before settling into the orbit we see now. But not every trace of that older system may be gone. One distant moon, strange and eccentric, may still carry the memory of what Neptune lost. Its name is Nereid, and it may be the survivor. If Triton was captured by Neptune, then the story cannot be only about Triton. It also has to be about what was already there. Because Neptune probably did not wait for Triton in an empty sky. Like the other giant planets, Neptune may once have had a more ordinary family of moons. Moons that formed near the planet. Moons that moved in the same direction as Neptune's rotation. Moons that circled in calmer, more predictable paths. We do not see that kind of system today, and that absence is one of the strangest parts of Neptune. Jupiter has 4 large Galilean moons, each one a world in its own right. Saturn has Titan, Enceladus, Rhea, Dione, and many others, along with its famous rings and small shepherd moons. Uranus, despite being tipped almost completely on its side, still has 5 major moons, moving in an orderly pattern around it. But Neptune is different. Neptune has Triton. And then, compared with Triton, almost everything else is small. Triton dominates Neptune's moon system in a way that feels unbalanced. It contains almost all the mass in orbit around the planet's moons. The other moons are much smaller, dimmer, and stranger. Some are close to Neptune, some are far away. Some have odd orbits. Some look like fragments rather than large ancient worlds. It feels less like a complete moon system and more like the remains of one. And that may be exactly what it is. If Neptune once had an original group of regular moons, Triton's arrival could have disrupted them. Not instantly in one dramatic flash, but over time, through repeated gravitational encounters. Remember what Triton's first orbit around Neptune may have been like. It probably was not the smooth, nearly circular path it follows today. A newly captured object would likely enter a stretched orbit, swinging far from Neptune and then plunging much closer. And because Triton moved backward, it would have crossed through the region where normal prograde moons may have already been orbiting. That is a dangerous arrangement. A large moon moving one way, a family of smaller moons moving the other. Again and again, their paths could come close. Each encounter would pull on the smaller moons, bending and disturbing their orbits. Some moons might be thrown farther out, some might be pushed inward, some might collide with one another, some might break apart, some might crash into Neptune itself. Over time, the original system could be erased, not because Triton was trying to destroy it. Because gravity does not need intention, it only needs time. A large captured moon moving through the wrong part of a moon system can act like a gravitational wrecking ball. With each orbit, the system becomes less stable. The smaller moons lose their neat paths. Collisions become more likely. Debris spreads. Fragments gather. New small moons may form from broken pieces. And after enough time passes, the original family is gone. What remains is a system that looks like Neptune's. One enormous captured moon. A few small inner moons, a distant, strange survivor, and a history that feels incomplete. This is where Nereid becomes important. Nereid is one of Neptune's outer moons. It is much smaller than Triton, but still large enough to matter. Its orbit is unusual. It does not circle Neptune in a neat, close, gentle path. Instead, Nereid follows a highly stretched orbit, traveling much closer to Neptune at one part of its path and far away at another. For a long time, that strange orbit made Nereid seem like another captured object. That would be an easy explanation. A distant, irregular moon, moving on an eccentric orbit, might simply be something Neptune grabbed from outside. The outer solar system contains many such objects, and giant planets can collect them. But Nereid may be more interesting than that. Some recent studies have suggested that Nereid might not be a captured Kuiper Belt object at all. Its surface may look less like a foreign icy body and more like a moon that formed in Neptune's own system. If that is true, then Nereid could be something remarkable, not another intruder. A survivor. A moon from Neptune's original family, thrown into an extreme orbit when Triton arrived. Imagine that. Before Triton, Nereid may have moved in a calmer path. It may have been part of a more normal moon system, one that formed with Neptune long ago. Then Triton entered the system, huge, backward, and unstable. The gravitational balance around Neptune changed. The original moons were disturbed. Many did not survive. But Nereid may have been thrown outward instead of destroyed. It may have escaped the worst of the chaos, not by remaining untouched, but by being pushed into a strange, distant orbit where it still travels today. In that sense, Nereid may be a kind of witness, a small, pale record of the system Neptune had before Triton. It does not tell the whole story. It cannot speak. It cannot show us exactly what happened, but its orbit and composition may preserve a clue. It may carry the signature of a moon system that no longer exists. This makes Neptune feel less empty and more haunted. When we look at the planet today, we see a quiet blue world surrounded by a strange collection of moons. But hidden behind that quiet picture may be a violent history. There may once have been more moons moving in order, more worlds circling Neptune in the direction they were born to move. Then Triton arrived, a captured world from the Kuiper Belt, a moon moving backward, a body large enough to dominate everything around it. And after Triton, Neptune's system was never the same. The small inner moons may also be part of this aftermath. Some of them are irregularly shaped, dark, and small. They may not be untouched survivors from the beginning. They may be second-generation bodies, pieces of older moons that were broken apart and later gathered again. If this is true, then Neptune's inner moons are not merely minor objects. They are rubble with history, fragments of a lost architecture, pieces of a moon system that was shattered, scattered, and rebuilt after Triton's capture. This idea gives Triton's story a much wider meaning. Triton did not just change its own fate when it became Neptune's moon. It may have changed the fate of everything around Neptune. It may have transformed a normal satellite system into the strange system we observe today. It became the dominant moon. It may have helped destroy or scatter the moons that came before. It may have left behind Nereid as a distant survivor and the smaller inner moons as fragments of a broken past. And then, slowly, after the chaos, Triton settled. Its orbit became more circular. The violent close passes became less extreme. The system quieted down. The debris found new paths. Neptune became the planet we see now, with one massive backward moon and a handful of smaller companions. But the quiet is misleading. It is the quiet after a storm, and Triton still carries the storm inside it, because the same gravitational forces that reshaped Neptune's moon system also reshaped Triton itself. Capture did not simply place Triton into orbit. It heated the moon. It flexed the interior. It may have melted ice beneath the surface. It may have created the conditions for geological activity that should not exist so far from the sun. This is why Triton is so different from an ordinary captured object. It was not just taken. It was transformed. A world from the Kuiper Belt became a moon. A moon system may have been broken. A frozen interior may have been warmed. And billions of years later, when Voyager 2 finally arrived, it found a surface that did not look ancient and dead. It found a world with smooth plains, strange terrain, a thin atmosphere, and geysers rising into the cold. That discovery is where Triton stops being only an orbital mystery. It becomes a physical world we have actually seen, but only briefly. Only once. For a few hours in 1989, a spacecraft from Earth passed through Neptune's system and looked closely at Triton. Everything we know in detail about its surface began with that single encounter. Voyager 2 did not stay. It could not orbit. It could not return. It flew past, gathered what it could, and continued into the darkness beyond the planets. But in that brief moment, it showed us something no one expected. The captured moon was not dead. It was active. For most of human history, Triton was only a point of light, a faint companion near a distant blue planet, too far away for telescopes on Earth to reveal its true face. We could calculate its orbit. We could measure its motion. We could see that it moved backward around Neptune. But we could not stand close enough to know what kind of world it really was. Was it ancient and cratered? Was it smooth and frozen? Was it dead? Or was something still happening there? For more than a century after Triton's discovery, those questions remained mostly unanswered. Neptune was simply too far away. Even the best telescopes could only tell us so much. Triton was a mystery, hidden inside another mystery, a strange moon around a planet almost 3 billion miles from Earth. Then came Voyager 2. Launched in 1977, Voyager 2 was not sent to Neptune alone. It was part of one of the most ambitious journeys ever attempted. The spacecraft visited Jupiter, then Saturn, then Uranus, using the gravity of each planet to bend its path toward the next. This grand tour was only possible because the outer planets were arranged in a rare alignment. It was a chance that would not come again for a very long time. By the time Voyager 2 approached Neptune in 1989, it had already been traveling for 12 years. It had crossed the outer solar system, past worlds no spacecraft had ever seen up close, and survived far longer than anyone could casually expect from a machine built in the 1970s. And Neptune was the final planetary encounter. There would be no orbiting, no slowing down, no second pass. Voyager 2 would fly through the Neptune system once, take its measurements, capture its images, and then continue outward forever. That made the Triton encounter precious. Mission planners had to choose the spacecraft's path carefully. A closer look at Triton would mean sending Voyager 2 on a trajectory that would carry it away from the plane of the planets. It would end the possibility of any further planetary flybys. But Triton was too strange to ignore. A large moon moving backward around Neptune was one of the most important targets in the outer solar system. If there was any chance to see it closely, that chance had to be taken. So Voyager 2 aimed for Triton, not to orbit it, not to land, only to pass by, quickly, silently, and once. At Neptune's distance, even communication becomes part of the drama. Radio signals traveling at the speed of light take more than 4 hours to cross the distance between Earth and Neptune. That means no one on Earth could steer Voyager 2 in real time during the encounter. Every command had to be prepared in advance. Every camera movement, every instrument sequence, every moment of observation. The spacecraft had to perform on its own, far beyond the reach of human hands. And it did. In August of 1989, Voyager 2 swept through the Neptune system and gave humanity its first close look at Triton. What it found was not what many expected. A moon so far from the sun should have looked old. It should have been heavily cratered, frozen into stillness, covered with the scars of billions of years. That would have been the simple answer. A cold, ancient world at the edge of the planetary system. But Triton was not simple. The images revealed a surface that looked surprisingly young. Large regions had very few impact craters. Smooth plains stretched across the landscape. Strange rounded depressions covered parts of the terrain, giving it a texture unlike anything else seen in the solar system. Ridges and fractures crossed the ice. Bright polar frost reflected the faint sunlight. This was not the face of a completely dead world. It was a surface that had been changed. Something had erased old craters. Something had moved across the terrain. Something had resurfaced parts of Triton long after its formation. And then Voyager 2 saw the plumes, dark geyser-like eruptions rising from the frozen surface. On Earth, a geyser brings to mind hot water and steam. On Triton, the word means something far stranger. These were not boiling fountains in a warm landscape. Triton's surface is colder than almost any natural place we can imagine. Nitrogen itself lies frozen on the ground, and yet material was being pushed upward. Dark particles and gas rose into the thin atmosphere, then drifted sideways with the winds, leaving long dark streaks over the bright nitrogen frost. The plumes showed that Triton was not only shaped by ancient processes, it was active at the time Voyager 2 passed by. That discovery changed Triton forever. It was no longer just the moon that moved backward. It was a captured world with a living surface, not living in the biological sense, not alive like Earth, but active, changing, breathing through a thin nitrogen atmosphere, letting frozen material shift between ground and sky, revealing that even in the farthest cold, a world can still have motion. Voyager 2 also confirmed Triton's extreme environment. The surface temperature was around -235 degrees Celsius. At that temperature, nitrogen can freeze as frost. The atmosphere is incredibly thin, but still real. It clings to Triton like a fragile veil, just enough to carry winds, just enough to spread dark material from the geysers across the ice. Try to imagine that scene. A pale frozen plain under a black sky. The sun, no larger than a brilliant star. Neptune hanging nearby, enormous and blue, filling part of the darkness. And from the ice, a dark plume rising silently into an atmosphere so thin it is almost not there. No sound, no warmth, no familiar weather. Only frozen nitrogen, faint wind, and a world that should be still, but is not. For a few hours, Voyager 2 gave us that world. Then it left. The spacecraft continued beyond Neptune, out of the planetary system, carrying its instruments and its golden record into the dark. Triton fell behind, Neptune became a distant point, and humanity has never returned. That is one of the most remarkable parts of this story. Everything we know in close detail about Triton comes from a single flyby. One spacecraft, one encounter, one brief window in 1989. We have improved telescopes since then. We have studied Triton from Earth. We have used powerful observatories to learn more about its atmosphere, surface chemistry, and possible seasonal changes. But nothing has replaced what Voyager 2 did. No orbiter has mapped Triton. No lander has touched it. No modern spacecraft has flown through its plumes or measured its ice with today's instruments. The only close look we have ever had came from a machine that could not stay, and even that look was incomplete. Voyager 2 saw only part of Triton's surface in detail. Much of the moon remains unseen at spacecraft resolution. We do not know what lies across the far side. We do not know whether more plumes are active there. We do not know whether the strange terrain continues around the globe, or whether entirely different landscapes wait in the darkness. This is what makes Triton so powerful as a mystery. It is not unknown because it is unimportant. It is unknown because we have barely been there. A world larger than Pluto circles Neptune backward. It may have come from the Kuiper Belt. It may have destroyed or reshaped Neptune's original moons. It has a young surface, a thin atmosphere, and geysers rising from nitrogen ice. It may even hide an ocean beneath its crust. And we have seen it closely only once. For a short time, Voyager 2 opened the door. Then the door closed again. Since then, Triton has continued circling Neptune in silence, still moving backward, still carrying the memory of another origin, still keeping most of its surface hidden from us. But what Voyager 2 saw was enough to change the question. Before Voyager, scientists could ask, why does Triton move the wrong way? After Voyager, they had to ask something deeper. Why is this stolen world still active? Why does a moon so cold, so far from the sun, still show signs of change? And what source of energy could be working beneath the ice? Triton should be silent. That is what makes it so strange. It is far from the sun, locked in orbit around a planet that itself drifts in the cold outer dark. It receives only a faint fraction of the sunlight that reaches Earth. Its surface temperature is so low that nitrogen, the gas that fills most of our atmosphere, lies frozen on the ground as frost. This is not a place where we expect motion. This is not a place where we expect change. At first glance, Triton should be one of the most frozen, still, and ancient surfaces in the solar system, a world where every impact crater remains for billions of years, a world where ice is not soft or flowing, but hard as stone, a world where geological activity ended long ago, if it ever existed at all. But Voyager 2 showed us something different. Triton's surface does not look like a dead archive of the early solar system. It looks like a surface that has been erased and rewritten. In many regions seen by Voyager 2, there were surprisingly few impact craters. That matters because craters are one of the simplest clocks in planetary science. Old surfaces collect craters. Young surfaces have fewer of them. If a world has been sitting unchanged for billions of years, impacts from small bodies gradually mark it again and again. The surface becomes scarred. The older the surface, the more crowded those scars become. Triton does not show that pattern clearly across the terrain Voyager 2 saw. Instead, parts of it look geologically young. That does not mean Triton itself is young. It is ancient, like the rest of the solar system. But the surface we see may have been renewed much more recently. Something covered older terrain. Something smoothed it out. Something changed the face of the moon after the original craters were already there. This is the first clue that Triton still has energy. Not heat in the way we imagine it on Earth. Not volcanoes glowing red. Not rivers, storms, oceans, or rain. Triton's activity belongs to a different kind of world. A world where ice can play the role that rock plays on Earth, and where gases can freeze, move, and return to the sky. On Triton, nitrogen is one of the key materials. At Earth's temperature, nitrogen is invisible air. On Triton, it becomes frost, ice, and atmosphere, depending on small changes in temperature. A few degrees can matter enormously. A region that receives slightly more sunlight may allow some nitrogen ice to sublimate, turning directly from solid into gas. A colder region may allow nitrogen gas to settle back down onto the surface as frost. This gives Triton a kind of breathing cycle. Very slow, very thin, very alien. Its atmosphere is almost nothing compared with Earth's. A human standing there would not feel wind in any familiar way. Without protection, the cold and vacuum would be instantly lethal. But scientifically, the atmosphere is real. It responds to sunlight. It shifts with seasons. It can move dark particles from one place to another. It can carry the traces of geysers across the frozen ground. This is one reason Triton does not feel like a simple ball of ice. It has exchange. Surface to atmosphere. Atmosphere back to surface. Frost moving with seasons. Dark streaks carried by winds. A world can be almost airless and still have weather if we are willing to stretch what the word means. Then there are the plumes. These are among the most fascinating features Voyager 2 observed. Dark material rising from the surface, reaching upward into Triton's thin atmosphere, then spreading sideways in the wind. On the images, they appear as long dark streaks against bright frost, evidence that something erupted and then drifted across the landscape. The cause of these plumes is still debated. One possibility is that they are driven by sunlight. That may sound strange. At Neptune's distance, sunlight is weak, but Triton's surface is made of materials that behave in extreme ways. Nitrogen ice can be partly transparent. Sunlight may pass through a thin layer of clear nitrogen frost and warm, darker material beneath it. That trapped heat could cause nitrogen ice below the surface to vaporize. Pressure builds. The overlying ice cracks. Gas and dark particles burst upward. If this is correct, then Triton's geysers are not powered by deep internal heat. They may be powered by a cold version of the greenhouse effect, where weak sunlight becomes just strong enough to trigger eruptions beneath transparent ice. It is a delicate process. A small amount of energy, a thin layer of frost, a darker patch below, then pressure, rupture, and a plume rising into the sky. But sunlight alone may not explain all of Triton's mysteries. Because the plumes are only one part of the story. The surface itself shows signs of broader change. Voyager 2 saw smooth plains that may have been resurfaced by icy flows. It saw ridges and fractures that suggest the crust has been stressed and broken. It saw strange rounded terrain unlike anything else in the solar system. One of the most famous regions is often called cantaloupe terrain because it resembles the dimpled skin of a melon. It is not a formal landscape we see everywhere else. It is Triton's own strange pattern, rounded depressions, irregular textures, and a surface that seems to have been shaped from below. Scientists do not fully agree on how it formed. It may involve warm, buoyant ice rising upward through colder ice. It may involve slow deformation of the crust. It may involve cycles of freezing, relaxation, or resurfacing. But whatever the exact process, the important point is simple. This landscape did not form by impacts alone. Something inside or beneath the surface helped shape it. And this is where Triton becomes especially interesting. Because when we say geology on Triton, we are not talking about geology in the Earth-like sense. We are not talking about molten rock pushing through volcanoes or tectonic plates sliding over a hot mantle. On Triton, the materials are different. Water ice may behave like rock. Nitrogen ice may behave like frost. Ammonia-rich water, if it exists below the surface, may act like a cryogenic fluid. Cryovolcanism, ice volcanism, could happen when melted or softened icy material rises from the interior and reaches the surface. Instead of lava, a cryovolcano might release slushy water, ammonia, methane, nitrogen, or other volatile materials. Once exposed to Triton's freezing surface, that material would quickly solidify, spreading into smooth plains or filling older terrain. This may explain why some areas look so young. The old surface may have been buried. The craters may have been covered. The landscape may have been renewed by material rising from within. This is what makes Triton so different from a simple captured ice ball. It is not just strange because of its orbit. It is strange because the orbit may have influenced the interior, and the interior may have reshaped the surface. The capture event may have left more than an orbital signature. It may have left heat. When Triton was first captured, its orbit around Neptune was probably much more stretched than it is now. With every close approach, Neptune's gravity would have pulled and flexed Triton. That flexing could create friction inside the moon. Friction creates heat. Over time, this tidal heating may have warmed Triton's interior enough to drive geological activity. And even after the orbit became more circular, some of that internal heat may have remained. Triton also contains rock. Radioactive elements inside rocky material naturally decay over time, releasing heat. This radiogenic heat is not dramatic, but on an icy world, over billions of years, it can matter. Combined with the legacy of tidal heating, it may help explain why Triton has not become completely frozen and inactive. So the question is not simply, how can Triton be active so far from the Sun? The better question is, what did Neptune's capture do to Triton? Did it warm the interior? Did it melt deep ice? Did it create pockets of liquid beneath the crust? Did it help build a subsurface ocean that may still exist today? These are not small questions. They connect Triton to some of the most important worlds in modern planetary science: Europa, Enceladus, Titan, and Pluto. Worlds where ice is not just a surface layer, but a gateway to deeper chemistry and hidden oceans. Triton may belong in that group. Not because we have confirmed an ocean there, we have not, but because the evidence points toward a world that has more energy than it should. A young surface, plumes, a thin atmosphere, possible cryovolcanic plains, a history of tidal heating, a composition rich in volatile ices, and an origin in the same outer solar system population that gave us Pluto. All of these clues point toward complexity. Triton is not easy to classify. It is a moon, but not born like a normal moon. It is an icy world, but not simply frozen and dead. It is far from the sun, but not completely inactive. It is captured, but not merely trapped. It was changed. And that is the heart of the mystery. A frozen world from the Kuiper Belt was pulled into orbit around Neptune. The capture may have destroyed or scattered older moons. It may have heated Triton's interior. It may have helped create the young surface Voyager 2 saw. It may even have allowed liquid water to survive beneath the ice for far longer than anyone would expect at such a distance from the sun. The more we study Triton, the less it feels like an ordinary moon. It feels like a world caught between identities. Part Kuiper Belt object, part moon, part frozen relic, part active ocean world candidate. And all of those identities are tied together by one event, capture. Without Neptune, Triton might have remained another distant icy body beyond the planets. Interesting, perhaps, but isolated. With Neptune, Triton became something else. It became heated, reshaped, and held in a backward orbit that still tells the story of how it arrived. That is why the geysers matter. That is why the young surface matters. That is why the thin atmosphere matters. They are not just features on a cold moon. They are clues that Triton's story did not end when Neptune captured it. In some ways, that may have been when the most important part began. Because beneath the frozen nitrogen, beneath the strange plains, beneath the crust that Voyager 2 only glimpsed, there may be another layer to the story, a hidden layer, a dark ocean sealed away from sunlight, a place where the heat of capture may have survived long enough to keep water liquid under ice. And if that ocean exists, Triton becomes more than a stolen world. It becomes one of the most unusual possible ocean worlds in the solar system. Not a world born warm, a world made warm by gravity. If Triton has an ocean, then it may be one of the strangest oceans in the solar system. Not because it would be visible, not because waves would move under an open sky, and not because sunlight would ever touch it. If Triton has an ocean, it would be hidden beneath ice, sealed under a frozen crust, on a moon nearly 3 billion miles from Earth. It would be dark, cold, pressurized, and completely separated from the surface by layers of ice and frozen material. But its origin may be the most unusual part. Triton's ocean, if it exists today, may not be something it was always meant to have. It may have been created by capture. To understand why that matters, think about the other famous ocean worlds. Europa orbits Jupiter. Its surface is cracked and bright, and beneath its icy shell, scientists strongly suspect a global ocean of liquid water. Europa is constantly flexed by Jupiter's gravity and by the pull of nearby moons. That flexing creates heat, and that heat helps keep water liquid beneath the ice. Enceladus orbits Saturn. It is much smaller than Triton, but it has active plumes erupting from its south polar region. Cassini flew through those plumes and found evidence that liquid water, salts, and organic molecules are coming from beneath the surface. Enceladus is one of the clearest examples of an ocean world in action. Titan, also around Saturn, may hide a deep internal ocean beneath its thick atmosphere and icy crust. These worlds are fascinating because they show us that liquid water does not always need sunlight. A world can be far from the sun and still have an ocean, if there is enough internal heat. Triton may belong in that same conversation. But Triton's heat story is different. Europa formed in Jupiter's system. Enceladus formed in Saturn's system. Titan formed in Saturn's system. Their internal activity is connected to the environments where they were born. Triton was not born in Neptune's system. At least, That is what its orbit tells us. Triton seems to have come from somewhere else. A frozen Kuiper Belt world, captured by Neptune and forced into a new life as a moon. And during that capture, Triton may have experienced an enormous burst of internal heating. When Triton first entered Neptune's gravity, its orbit was likely not smooth and circular. It was probably stretched and unstable, swinging close to Neptune and then far away again. Each time Triton passed near Neptune, the planet's gravity would pull unevenly on the moon. The near side of Triton felt a stronger pull. The far side felt a weaker pull. This difference stretched and squeezed the entire world. Inside Triton, ice and rock would flex, layers would shift, friction would build, and friction creates heat. This is tidal heating. On Earth, tides mostly move ocean water. On an icy moon, tides can move the body of the moon itself. The entire world can deform slightly under the pull of a giant planet. It may not look dramatic from the outside, but over time, the energy involved can be enormous. For Triton, that energy may have been enough to melt deep ice. A frozen world from the Kuiper Belt may have arrived cold, rigid, and ancient, but after capture, Neptune's gravity may have warmed its interior from within. Ice that had been solid for billions of years could have softened. Melted layers could have formed. Water mixed with ammonia and salts could have remained liquid beneath the crust. In this way, Triton's capture may have created a hidden ocean. Not a surface ocean, not a blue sea under sunlight, but a dark internal ocean, trapped between an icy shell above and a rocky core below. That rocky core matters. Liquid water alone is interesting, but water in contact with rock becomes much more important. On Earth, some of the most unusual ecosystems live around hydrothermal vents on the ocean floor, where water interacts with rock and heat, producing chemical energy. These ecosystems do not depend on sunlight. They depend on chemistry. If Triton has a subsurface ocean touching a rocky interior, then chemical reactions may be possible there too. That does not mean life exists on Triton. We have no evidence for that. But it means Triton could have some of the ingredients scientists look for when they think about habitability: liquid water, rock, energy, and time. The question is whether that ocean could survive. Triton is small compared with Earth. It is far from the Sun. Its current orbit around Neptune is much more circular than it probably was just after capture. That means the strongest tidal heating may have happened long ago. Over time, the interior should cool, the ice shell should thicken, any ocean should slowly freeze. And perhaps it has. But perhaps not completely. Some models suggest that Triton's internal ocean could have lasted for billions of years, especially if ammonia or other compounds lowered the freezing point of the water. Radiogenic heat from its rocky core could also help. Even a small amount of long-term heat can matter when it is trapped beneath a thick insulating shell of ice. This is why Triton remains so important. It is not confirmed as an ocean world in the way Enceladus is. We have not flown through fresh plumes from a subsurface sea. We have not measured an induced magnetic field that clearly reveals a global ocean. We have not sent an orbiter to map its gravity or study its interior. But the possibility is strong enough to matter. Triton has the right history. It has the right composition. It has signs of geological activity. It has a young surface. It has an atmosphere and active plumes. And it has one of the most powerful heating events imaginable in its past, the capture of an entire world by a giant planet. That makes Triton different from almost every other ocean world candidate. If Europa has an ocean, it is because Jupiter's system helped sustain it. If Enceladus has an ocean, it is because Saturn's gravity and orbital resonances continue to feed it energy. But if Triton has an ocean, then that ocean may exist because Triton was stolen. A violent gravitational event may have taken a frozen Kuiper Belt object and changed its interior so deeply that liquid water could survive beneath the ice. That idea is profound. It suggests that habitability is not always something a world is born with. Sometimes, it may be created later, by accident, by migration, by capture, by a close encounter that changes a world forever. A frozen object drifting in the outer solar system may not seem like a place where liquid water could exist. But put that object in the right orbit around a giant planet, flex it for millions of years, heat it from within, and it may become something else. An ocean world. A world with chemistry. A world with layers. A world where the boundary between dead ice and hidden possibility becomes harder to draw. This is why Triton is more than a strange moon. It is a test case for one of the biggest ideas in planetary science. Can a world become habitable after it forms? Can gravity create conditions that did not exist before? Can a captured moon become an ocean world simply because its path through the solar system changed? We do not know the answer yet. But Triton gives us a place to look, and that place is waiting under the ice. Somewhere beneath the nitrogen frost, beneath the strange dimpled terrain, beneath the smooth plains and dark plume deposits, there may be a deep layer of liquid water. It may be mostly frozen now. It may be thin. It may be regional. Or it may still wrap around the moon as a global ocean. Voyager 2 could not tell us. Its instruments were not designed to answer that question fully. It flew past too quickly. It did not orbit Neptune. It did not make repeated measurements. It could not listen for the magnetic signature of a salty ocean beneath Triton's crust. So the ocean remains a possibility, a serious one, but still hidden. And that uncertainty is part of Triton's power. It forces us to sit with a question we cannot yet close. A moon that should not belong to Neptune may also hide an ocean that should not exist so far from the sun. A world captured by gravity may have been warmed by the same event that imprisoned it. And if that is true, then Triton's story is not only about loss, it is also about transformation. Neptune may have stolen Triton from the Kuiper Belt, but in doing so, it may have made Triton into something far more complex than it ever would have been alone. A captured moon, a reshaped world, a frozen body with a possible ocean in the dark, and perhaps one of the most important places we have not yet returned to. The most important thing about Triton may be that we still do not know it well. That sounds strange to say about a world we have already visited. Voyager 2 flew past it. We have images. We have measurements. We know its orbit. We know its temperature. We know it has nitrogen ice, a thin atmosphere, strange terrain, and geyser-like plumes. But compared with what Triton may be, we have only seen the beginning. Voyager 2 gave us a glimpse, not a full portrait, a glimpse. It flew past Triton once, in 1989, moving too fast to stay, too far from Earth for real-time control, and too limited by the technology of its time to answer the deepest questions we ask today. It showed us part of the surface. Not all of it. Large regions of Triton remain unknown at the level only a spacecraft can reveal. We do not know whether the unseen terrain is covered in the same strange patterns Voyager 2 photographed. We do not know whether there are more active plumes. We do not know whether the far side contains younger planes, deeper fractures, fresh deposits, or features unlike anything seen anywhere else. Triton is not a solved world. It is an unfinished map. And that matters because every major clue we already have points toward a deeper story. The backward orbit says Triton was captured. The composition says it may have come from the Kuiper Belt. The comparison with Pluto says it may once have been a free icy world. The shape of Neptune's moon system suggests Triton may have disrupted what came before. The young surface says something has renewed the ice. The plumes say the surface is not completely still. The atmosphere says nitrogen still moves between ground and sky. And the possibility of a hidden ocean says the most important part of Triton may not be visible at all. It may be beneath the surface, under the frost, under the crust, under the quiet plains Voyager 2 saw only for a moment. That is why returning to Triton would be so powerful. A modern spacecraft could do what Voyager 2 could not. It could map the surface in far greater detail. It could compare old terrain with new terrain and search for changes across decades. It could study the plumes, if they are still active. It could measure the atmosphere directly. It could examine the chemistry of the surface. It could search for magnetic clues that might reveal whether a salty ocean still exists beneath the ice. Most importantly, it could turn Triton from a mystery built on one brief encounter into a world we truly begin to understand. Because right now, Triton sits in a strange place in planetary science. It is one of the most interesting moons in the solar system, but also one of the least explored among the major worlds. Europa has become a major target because of its ocean. Enceladus changed everything when Cassini flew through its plumes. Titan has drawn attention for its thick atmosphere, organic chemistry, and strange methane cycle. Triton belongs in that conversation. But Triton has one thing the others do not have: its origin story. Europa, Enceladus, and Titan are fascinating because of what they became inside the systems where they were born. Triton is fascinating because it may have become extraordinary after being taken from somewhere else. It is not just an ocean world candidate. It is a captured ocean world candidate. A place where habitability, geology, and internal heat may have been shaped by a violent change in orbit. A world that may have been transformed not because it formed in the perfect place, but because Neptune pulled it into an entirely new life. That idea reaches beyond Triton. It asks whether other planetary systems might have their own captured moons, their own stolen icy worlds, their own objects from distant belts, pulled into orbit around giant planets and warmed by tides. If that can happen here, around Neptune, then perhaps it can happen elsewhere too. Maybe some worlds do not begin with the right conditions. Maybe some are given them later, by gravity, by accident, by capture. Triton reminds us that the solar system is not a still museum. It is a history of movement. Planets migrate, orbits shift, worlds collide, scatter, and sometimes get caught. A body born in one place can end up somewhere completely different, carrying the chemistry of its birthplace into a new environment. That is what makes Triton so compelling. It is a moon, but it does not feel like a moon in the ordinary sense. It is a Kuiper Belt world, living in Neptune's sky, a sibling of Pluto that did not remain free, a captured body that may have destroyed an older moon system, a frozen surface that refuses to look ancient, a possible ocean world made not by warmth from the sun, but by the memory of gravitational violence. And still, after all that, it moves backward, quietly, patiently, around Neptune. Every orbit repeats the same message. This world did not begin here. It is easy to imagine Triton as lonely, a pale moon circling a distant blue planet, far from the sun, far from Earth, far from the region where humans have sent most of their machines. But loneliness is not the whole story. Triton is also a record. It records the Kuiper Belt in its ice. It records Neptune's past in its orbit. It records capture in its backward motion. It records internal heat in its young terrain. It may record an ocean in ways we have not yet measured, and it records our own limits, because we have only seen it once. Somewhere on Triton, beyond the areas Voyager 2 photographed, there may be landscapes no human eye has ever seen. There may be fields of nitrogen frost stretching into darkness. There may be fresh dark streaks from plumes that still rise into the thin atmosphere. There may be fractures cutting through the ice, hinting at movement below. There may be smooth plains formed by ancient cryovolcanic flows. There may be clues waiting on the surface that could tell us whether Triton still has warmth inside. Or perhaps the greatest clue is hidden deeper, a dark ocean beneath the ice, silent, cold, sealed away from the sun. Maybe it is still there. Maybe it is mostly frozen. Maybe it once existed for billions of years and is now fading. We do not know. And that is the honest ending to Triton's story for now. We do not know. But what we do know is enough to make Triton one of the most extraordinary worlds in the solar system. It should not move the way it moves. It should not look as young as it looks. It should not be as active as Voyager 2 found it to be. It should not feel so connected to Pluto while orbiting Neptune. And perhaps that is why Triton matters, because it reminds us that worlds are not always defined by where we find them. Sometimes, to understand a world, we have to ask where it came from, what changed it, and what it lost along the way. Triton may have lost its original path around the sun. It may have lost a companion. It may have left behind the Kuiper Belt. It may have entered Neptune's system through an event powerful enough to reshape moons, melt ice, and write a backward orbit that still survives billions of years later. But in that loss, Triton became something rare, a captured world with a story no other large moon can tell. A frozen body that may still hide liquid water, a moon that does not belong, and yet has become one of the most important clues to how strange, flexible, and surprising planetary systems can be. Far from Earth, Neptune continues its slow journey around the sun, and Triton continues circling it backward. Not loudly, not dramatically, just steadily, in the deep blue dark. A moon that remembers another home, a world that still keeps most of its secrets. And one day, perhaps, when another spacecraft finally crosses the long distance to Neptune, we may look again at Triton's frozen face and discover that the moon that should not belong to Neptune has been waiting all this time to tell us what happened in the coldest chapters of the solar system. Until then, Triton remains what it has always been since Voyager left it behind. A stolen world, a silent mystery, and one of the most beautiful reasons to return to the edge of the solar system.